In the last video, I gave an example of a new requirement coming to light late in the development process. Let's quickly revisit this requirement. We were looking at a school management system ready for deployment. It includes features for generating student report cards. Just before deployment, it is noticed the system only supports PDF export, but doesn't print directly to the network printers, which I use daily. In other words, when the teachers got hold of the software to have a look at it, to see what they thought of it, they noticed that whenever they wanted the student report, the system generated a PDF file that they then would have had to have downloaded themselves and printed it. Now, if they have a class, we'll say, of 30 pupils, they don't want 30 PDFs. They might want to keep them and store them on their own computer, but if they want to get these printed, they would much prefer for there to be something part of the software system where they can simply click on the button and it'll print to the network printer all of the report cards for a specific class, for example. A new requirement is identified. The system must support direct printing to network printers using the school's standard print configuration. This is what's been identified very late in the software development lifecycle. In this video, we'll explore how this impacts each phase of the development lifecycle. In other words, we found this late requirement. What should a software team now do to make sure that it is implemented to the satisfaction of the stakeholders, i.e., the teachers in this case? Let's consider why it might have been missed. The team prioritized digital features like exporting and emailing, assuming printing was separate. But teachers need fast direct printing for dozens of reports, as we've already discussed. It's important to realize that this kind of requirement often pops up when real users start interacting with the system in their actual environment. In this case, the teachers looking at what the software is capable of doing and then realizing there's something that they would be doing frequently that hasn't been implemented by the software development team. So they're requesting it late, as I've said already, in the development cycle. Let's walk through how a late discovered requirement, like needing printer support, affects each phase of the software development lifecycle. The team must update the analysis documentation to include printer compatibility. This often triggers stakeholder reviews and reapproval. In other words, the analysts will update their documentation, give it a new version number, but also they would discuss it with the stakeholder to confirm that what they have produced in the requirements document is precisely what the stakeholder wants. The design architects must revise the system design, adding support for printer drivers, network protocols, and any necessary UI changes. UI meaning user interface changes, because clearly there'll have to be a button somewhere or a drop-down menu that allows the teachers to print off a batch of student cards. So the designers will alter the design documentation and save it under a new version number. The design documentation is then passed over to the computer programmers so they can get on with the implementation phase, the coding phase, to make the appropriate changes to the software system. So coders have to revisit the implementation to write new code to handle printing, possibly integrating third-party libraries and APIs. And they will do so guided by the release of the new design documentation. In testing, QA teams create new test cases for printer functionality, such as checking for issues like offline printers or paper jams. And QA, by the way, stands for quality assurance. Let's consider a typical test case. The computer programmers will have wrote code to batch print a number of student report cards. It's bound to happen that somebody will have switched off the main printer that does the printing on the system, or there might be a paper jam. So, what the testers would have to do is to switch off the printer and see if the software can cope with it. So, it would have to pass that test. So, the testers, the quality assurance team, make sure it will work for issues like that, issues that will definitely happen when the software is being used. And that's what we mean by a new test case. Now, the programmers will be focused on getting it working, look at the printer working, and they may forget, oh, wonder what will happen if somebody switches the printer off. Their focus is on getting it working, not necessarily deciding what the issues are. But that's where the quality assurance teams come in. They make sure things like that are thoroughly tested. Most programmers will obviously know to make sure their software will react when there's a paper jam, but you have to test for it. And that's the purpose of the quality assurance teams, to test the code to make sure it works. The testers, of course, would be hoping that the software system would report back to whoever's using it, oh, by the way, the printer's offline. Of course, it could be the case that this need for the capturing of the fact that a printer could be switched off was not expressed in the design documentation. So perhaps there could be a need to go back there and alter the design documentation to ensure that there is accuracy between all of the phases of the software lifecycle. During the maintenance phase, support teams prepare for printer-related issues. This will usually involve creating documentation to help users troubleshoot. In other words, say, well, look, if you see this dialog box popping up on your screen, it's most probably telling you there's a paper jam or somebody switched the main printer off. So documentation would have to be released that helps the users with the software system that they are using. As you can see, a single late requirement can ripple through every phase of the software lifecycle. It'll require changes to the analysis documentation, the design documentation, and also alteration to code. The code that's being produced, the new code that's being produced to meet the requirements will have to be tested appropriately, and documentation for the users on how to use the system would have to be altered and updated. All of this adds time, cost, and complexity. Catching requirements early is the key to smoother development. The reality is, new requirements will always come to light throughout the development of the software. So why not plan for it? Why not make an assumption that there will be new requirements coming to light throughout the development life cycle? The thing about the waterfall model, it's suggesting you do all the analysis, finish it, do all the design, finish it, then do the coding, then do the testing, and it gives the impression that that's the way in which you should go about developing software. But we found that there is a problem when you find requirements late in the development lifecycle. One of the things to bear in mind, there's something that is referred to as creeping requirements. And this means that you may have thought you've done a good job of the analysis and you found everything that the customer wants, the stakeholder wants. But as you go through the software development, when you say get to the coding phase, somebody then says, I'm sure they would want this. And then it makes you realize that you haven't done all of the analysis. You may have missed some of the requirements needed by the stakeholder. They may not have told you what the requirements are. But the point is, the requirements for the system have been missed. And on large projects, it's fair to say that when you've finished all the requirements, by the end of the cycle, 40% of the requirements of the finished system will have been missed right at the start. That's a typical number. 40% are missed. So why not plan for it? Why not say, well, look, we're going to not know all of the requirements. So is this waterfall model useful for us to develop software? Now, the answer is in the sense that it tells you what all of the phases of the software lifecycle are. But the notion of do the analysis, finish it, do the design, finish it, do the coding, finish it, doesn't bear out in practice. But it is a good model for you to focus in on when you're learning to be a computer programmer. Because I'd like to stress with this video that software development isn't all about coding. And it's worth mentioning that an analyst may not even know how to code. What they're good at is communicating with the stakeholders to find out what the stakeholders actually want the system to do when it's finished. Now, there'll be more of this later in the playlist. The bottom line is that it is difficult to deal with late requirements with the step-by-step nature of the waterfall model. And we will be looking at another model later in the playlist, namely the agile approach to the development of software systems, to see how that deals with creeping requirements.